Hey, John here. Recently, we're looking at an issue that was posted by Dino Wiggle here. I went ahead and modified my VDP board by changing the capacitors I use, these so-called load capacitors that go on the crystal oscillator. I used 27 POF in the original design. He's suggesting that maybe 43 would be better because the frequency is closer to what it really is supposed to be. Now, I had hopes that maybe this would cause the color to change a little bit for the better on the output of the VDP board. And, yeah, to my eye, it made no difference at all. So I figured, meh, was my walkaway on this. However, there are some other side effects. A big thank you to all my Patreons. Really help out, make all these things possible, especially if I got to buy new parts in order to make more tests and things. Thank you, thank you, thank you. So, as I showed before, after having changed the capacitors, my first pass, my first prototype test version of Breakout, my Breakout game here, has some weird behavior. Notice that the speed at which the ball moves changes all the time. Now, it really is confusing because it changes its speed each time it bounces off the wall, which really doesn't make any sense at all because the code uses the same logic no matter which direction it's moving. Now, what is really confusing is that some other games that were written by somebody that goes by Production Dave on the Discord channel, some early versions of the games that he wrote were very jumpy to me and worked like this. It would be like weird for no reason. They'd be running at different speeds at different times and stuttering and doing all these weird things. But on his system, he built his own VDP. They work fine. Now, the weird thing about all this is if I go grab his games, let me go ahead and kill mine here. And go over to Drive E where his games are. I think they're on my Drive E. There we go. I've got a Tetris 1 and then a Tetris. So the difference between these two versions of the games is that one of them reads this status register directly to see the frame flag in order to figure out when the video screen has moved on to the next frame. The other version of the game reads the same status using a bodge wire that I'll talk about in a minute that allows us to improve the stability of the game. So here's the version that he had originally. Now, if we were to play the game, you can see this works pretty well, especially if I just drop it. Notice what happens every time I just say drop the piece. It moves nice and smoothly flowing. It works fairly well. But once in a while, you'll notice the screen, when it redraws itself, it kind of glitches a little bit. I believe that that happens as a result of what I've talked about before, the metastability problem when you read this frame flag, the overlapping clocks of the Z80 and the VDP, all running independently of each other, causing the resetting of this flag to occur at a weird time while it's also being set. And therefore, if you're going to use the presence of that frame flag to measure every one of these screen refreshes, you might miss one every now and then. Or, alternatively, you could end up seeing two refreshes in a row very quickly, in which case your game would run artificially fast, for example. Arguably, Production Dave's game works much better with the new capacitors and worked very poorly with the old ones. I'll show you the old version in a minute. And mine used to work fine with the old capacitors, and now it is awful with the new ones. I mean, look at that thing. Even when I move around the joystick, you can see it moves faster and slower like the ball does. The left and right motion on my game is supposed to go 3 times faster than the up and down. And you can see everything changes speed when it's running fast versus slow. And it seems to be tied to this notion that you bounce the ball off the wall and the speed changes. But that, like I said, I think that is not something that you want to take into account in this scenario, because what's really happening here is the clock phases of the Z80 and the VDP are such that maybe now the clocks are closer to being in sync with each other than they used to be. So if there is some sort of an error, it'll continue over the course of time in this version of the oscillator design versus the ones with the other capacitors. So let me go ahead and put the old capacitors back in, and I'll show you what I saw if you didn't notice it yourself, if you've seen this game running in the past. So now we're back to where I started with the 27s. The only difference is that I've switched those two capacitors. Moment of truth here, people. Now let's see what happens with breakout. Because this one really looked like it changed to me in a huge way when the game ran. Now you can see it's working quite nicely again. No, all I did here was just simply change those capacitors, and that's it. Now, it could be a mental thing here. If we watch this thing go, it does appear that maybe once in a while it might stutter a little bit. It doesn't look too bad. Maybe watch the ball move. That looks okay. This one kind of moves too fast anyway in these directions to really get a good view, but I don't know, psychologically it might be stuttering a little bit, but this is 1,000 times better than the way it was. That's for sure. All right, so let's now move on to looking at Tetris. Now, last time I ran Tetris was this first version over here, and I thought it played absolutely horribly. In production, Dave and I spent a lot of time trying to figure out what was going on here. What we originally thought it was some sort of a software bug, but it did behave differently on his retro board than it did with mine. So let's hit this button. Oh, I saw a big glitch when the game started. And if you drop these parts, what I noticed is that when you drop them, it really wants to stutter and just do crazy wonky things when these parts, and it also, I cannot express how sluggishly this game responds to the joystick right now. It really isn't so good. Although I would argue I've seen it do worse. Come on. Trying to just stack them up. And it's having all kinds of problems dealing with it, responding to the joystick and so on. All right. So here it goes. It's going to give me my score, which kind of stinks right now. Of course, if that got me 177 and the high score is 660, I'm going to argue since my last build. Okay, because, I'm testing things here is the whole point. All right. Now, if we drop these, drop it, you can see it kind of go, and then it stops, and it's just not right. Yeah, it speeds up and slows. It's just terrible, especially compared to what happened the last time we played it. Let me show you another version of the same game. This is Tetris 1. Now let's run the regular old Tetris here. Come on, stop the game. Hit Control-C. This should boot. There we go. Tetris. There we go. This version works ever so slightly different. Now, I noticed it glitched a lot when it started up, but that's a subject for another video. When the game plays, if I drop these, look at how smoothly it works now. They're just down, down, down. It is perfection. So what changed between those two, right? Let's go back to a breakout game now, which is sitting in here. This goes back a month or two since the last time I really was able to make progress on this. I just added some code in here, this if1. This is the original version. I talked at some length about how this works in my video in the past. In fact, here's a whole comment on it. It talks about what happens when we read the frame flag and the whole metastability problem that we see, or more accurately, it's really just a race condition on that. We're violating the setup and hold time is what's really happening. We can talk about that some other time if you're not familiar with the problem. Here's an alternate version of the exact same code. Let's run it first and see what happens, and then we'll look at the details. Now, this, of course, is part of the example file system image where I give you, a make file and show you how to build your own ASM files, compile them to comp files. So you can create a file system and stick it on your own drive. Now, you'll notice this seeks to 1 times 16K. I talked about that, I believe, in the past as well. What that's all about is it builds a file system and copies it onto drive B. Drive A is 0 times 16K. 1 is B, 2 is C, and so on. So what I did there is I just replaced all the files on file system B. I put the card back in Retro and rebooted it. So here we go. This is a newer version of Breakout. So let's go ahead and run this one and see what happens. Okay. Now this is running smoothly. I'm going to argue it's probably running more smoothly than it did. It already looks more reasonable. The ball, I thought, jumped around. It may have been subconscious, more so than anything else, but it's bouncing around nicely. If I move it back and forth and up and down here, it's hard for me to really conclude that this is any better than it was, okay? Now, this is with the 27 puff capacitors. This is an infinite amount better than it was with the 43s, which didn't work right at all when we pulled the frame flag. While the 47s were in there, I also ran this version of Breakout, and it also behaved just fine and dandy. So my takeaway on this whole thing is that the direct reading of this flag bit in a polling mode causes this setup and hold time violation and can cause you to drop or duplicate frames. You might see it set when it's not supposed to be set, or you might not see it set when it should be set. It's as simple as that. It's obvious that the designer of this chip intended that you must use the interrupt signal and then read it after that interrupt pin has reported itself as having been activated. Flat out, no other options are reasonable. Further, if you're going to operate in that way, let's see, where's the weight? You have to deal with the fact that, in theory, the chip is always unstable. And here's my rationale behind that. All right, here's the code that kind of works, but it's highly dependent on, the exact oscillator speeds, maybe the duty cycle of the clock. All kinds of weird stuff can happen to cause the Z80 to experience a different phenomenon when it's trying to read that frame flag using this technique here. Let's look and see what I did down here to, I'm air quoting, fix it, okay? Instead of reading the VDP register directly, I'm going to read joystick 0. Here's the VDP schematic, okay? Joystick 0 is this guy up here, U6. Now, what I've done is I've hooked up the pin 4 on U6, which is the bit number when you get 0 through 7, right? So this is your 1s, your 2s, your 4s, your 8s, 16s, 32s, and so on. Your powers of 2 when you read this in on the data bus over here. So what I did is I connected pin 4 of U6 over there up using that bodge wire to this interrupt pin right here on pin 16. So I could now, if I wanted to, put this jumper in there, put the Z80 into mode, 1, I suppose, so that this, if it generates an interrupt, it'll go to the one and only handler, and I would have to use mode 1 and not mode 0 and not mode 2 because the Z80 requires a handshake from the peripheral device if you use the other modes, which this thing does not do. So it leaves you with mode 1, which says, if I have the numbers right in my head, that if this thing ever generates an interrupt, go to the one and only one place to handle the interrupt that has occurred. And in that handler, you can then go read the frame flag bit from the VDP. That's not entirely unlike what I've done right here. But I don't want to have to use mode 1 interrupts on my retro board. Yes, you could run a bodge wire from the interrupt output of the VDP and connect it over to like the CTC or one of the SIO pins that could generate an interrupt, like, your whatever it is, like CTS or something like that, that is capable of generating an interrupt to the host to let the Z80 know that that pin changed or whatever. You can play games like that, okay? And that's all fine and dandy. Knock yourself out. But we got two separate boards. I don't want a wire running between the two boards. So what I've done is I've connected up to joystick input number 0, and there's your mask. So I'm going to read that input bit. I'm going to ask if it's set. Let me get a better font that's more readable. There we go. If I can't read it on my phone, I consider it worthless. Too many videos have too small of fonts. I try to avoid that. Feel free to let me know if I forget. I always try to remember to use this size font because it allows me to actually see the text even on my phone. If that ain't the case, it's worthless, in my opinion. Okay, so again, here's me reading the VDP flag bit, and I end it with hex 80 because that's the most significant bit. And if it's not on, I go in and I spin around this loop here, okay, waiting for it to go on. When it goes on, I go to return and go on a merry way. This one down here, instead of reading the flag bit directly from the VDP, I get to take a peek at it through the joystick register, that buffer, okay? And I end it with 2 because that's where the bit is. It's on the second bit. And then if it is not 0, right, it's the opposite up here. If it is high, then it is not asserting an interrupt because, remember, if we go back down here to the pin out of the chip, the interrupt signal over here is active low. So if this pin here is a 1, a high, it is not asserting an interrupt. And when it becomes a 0 is when we want to react. So that's why if it is not 0, we spin around in the wait loop. Now, don't forget to do this. When you're done with all that rigmarole, you do have to read the VDP register, because if you don't, it does not know that you have seen and are reacting to the fact that that flag has been set. This is what resets the flag. Now, the difference between these two codes here is that we know that we have seen it set before we read the register, which has a side effect of resetting it. If you do it this way, what happens is you can be reading it while the VDP is setting it and resetting it all at the same time. And that's what causes this stupid, annoying problem. And it seems that the exact speed of the oscillator running on the VDP over here, these load capacitors are what we were just screwing around with. I originally had 27s. We went to a 43. It changed the behavior. Why did it change the behavior? Well, there could be a subtle speed difference in how this thing runs in relation to the speed that the Z80 is running. Keep in mind that this is a completely autonomous and different oscillator than the one that's running on the Z80. These cannot be synchronized. Absolutely not going to happen. They'll slowly drift in speed and they'll walk around relative to each other a little bit, okay? Changing these load capacitors can change the speed and change the rate at which they walk around relative to each other. They could also change the duty cycle, and by that I mean, how long this oscillator inside the VDP is a 1 versus when it's a 0. Maybe it stays high 80% of the time and low 20% of the time, and that can cause this chip to behave more differently than if it's high 50% of the time and low 50% of the time. We have absolutely no way of knowing if that is the case because we don't have any reference to a free-running clock coming out of this chip. This pin here on 38, this is the so-called Grom clock, which is this thing divided by like 24 or something like that. Now, the fact that it runs at, this divided by 24 means it's going through a bunch of flip-flops or counters and registers and things like that. And once the division has been completed, most likely it's running at a 50-50 duty cycle. My point is, we can't really know the effect of these load capacitors on the shape of the square wave that's operating the inside of the 9118, which could have an effect on what it does if it's asserting this while someone's reading the status port at the same time. Therefore, we really don't want to pull this register 7. And, of course, they note, just like I did, keep aware of the fact that you actually need to be able to read it each time a frame goes by in order to get a new interrupt for the next frame. Now, I have noted that this is going to be unstable at any speed, right? Why? Okay, if I'm polling, or if I'm getting an interrupt that causes a handler to come in and then do the read of the VDP register and the interrupt handler and stuff like that. In either situation, what happens is the interrupt pin will have been asserted for some period of time prior to me going into this wait poll loop here. I mean, I could have been off doing something else, which caused me to start doing this later than I would like to. And later meaning if the interrupt status bit is already on before I get to the wait loop, right? Well, it could also be that if I'm using interrupts to do all this, I could have the interrupts disabled, or the Z80 could have nested interrupts. There can be all kinds of reasons that cause an interrupt handler to be reacted to in a delayed fashion. Just like it would be, I took too long to do what I was supposed to do with my game before I got to the wait loop. The point is, what if I'm late before I get to the wait routine, or I have interrupts disabled for a little while, and then I re-enable them, at which point the interrupt is asserted, which would have the same effect of me calling my wait polling loop a little bit late. Same situation, right? Well, what if I'm late enough that I miss an entire video frame, which can happen, by the way. It seems like an eternity to waste a whole 60th of a second. In this case, it would be a field, right? But this is running at 60 hertz. So if we waste an entire 60th of a second doing something, disk I/O and things like that can definitely cause these types of things to happen. I can then come in here and start reading this at the point in time when the VDP wants to assert the interrupt signal a second time when it's already been asserted, which can still cause this same race condition weirdness to take place. Obviously, if I miss an entire one, then I will just simply count one fewer than I should have, and you could argue, well, who cares if you're that late anyway? My point is, as long as you're not actively monitoring the interrupt pin, either with an interrupt, tying it to the interrupt to the CPU, or you're already polling it by using this code here, looking at the bit on my joystick 0 port, waiting for it to happen, okay? And you get here quickly enough in a normal case, if you do not have interrupts being turned on a retro board for some other reason that could take an arbitrarily long amount of time between this instruction here and this one here, by the way, as well, right? As long as you do this soon enough after the interrupt status pin has been asserted, but not too soon, because we know this can do it too soon, right? Then all is well. But if you do it too soon or too late, then not so good. So this just blows, all right? A lot of systems back in the day had problems like this. And we end up with, well, it's good enough kind of software. So finally we have a stable running game here, as long as we don't pull the lousy frame flag. And I've talked a little bit about this in the past. I will go ahead and commit this change. And I'm also going to have to now update the schematic, I think, and actually run a track over here to pin 4. I should put a jumper in there so we have the option, just like the interrupt over here. You're going to have the option to run it. I mean, nothing wrong with running mode 1 interrupts. It absolutely will work if you want to do that. Of course, if you run mode 1, you may have trouble if you decide to also have interrupts on from the CTC and or the SIO at the same time, which is why I went ahead and put a jumper here. What I'm going to do is come up with a new rev of this board, not critical, because the bodge wire is real easy to do. You saw it on the bottom of my board. You just go ahead and grab a little teeny piece of like Kanyar wire wrap wire and connect it up to pin 16 of the 9118, and then run it over here to pin 4 of U6. That's a pretty easy task to do. As far as bodge wire hackery is concerned, this is the best scenario. You don't have to cut any traces to put this thing in here. You just simply add the little wire. Now, if you've not already built a VDP and you're excited about doing so, why don't you wait until I release this along with the new Gerbers. It'll be revision 2. Revision 0, as you recall, had the power hooked up backwards on the DRAMs, which drove me absolutely nuts. That's this up here, okay? Revision 1 is what we got here. I'll move on to Rev 2 with the, another jumper in order to make that work. All right? So we're moving along in a forward direction here. I strongly urge everybody that has one of these already made to add the bodge. Otherwise, the games that I know are in progress won't be able to work on your board. If your board runs and the thing just sits there seized, it will most likely be because the game is pulling pin 4 over here and it never sees it change. So we need to really make sure that this interrupt signal here is routed over to one of these unused inputs over here. We just arbitrarily chose this pin 4 over here. All right? For this purpose, okay? Now, if you don't want to solder on your board, by the way, there's another way to do this. Notice that pin 4 over here, A81, is also connected to a test header, A8 pin 1 right here, pin 5, on this J5 over here. And there's a nice pin sticking up on your board. You can just go get one of those Arduino jumper wires and stick it on here and then run it up through the air and then connect it over here to J6 pin 1. Yeah, there's a diode in here and that'll have some impact on the situation. However, because this pin also, A8 pin 1, has a pull-up resistor over here, it'll be fine. Okay, even without the pull-ups right now. On my VDP, I didn't even put these on yet because I wanted to make sure everything worked before I used up all the parts. As long as you use an LS244, this thing most of the time will think any floating pin over here is actually high anyway. Most TTL chips, most of the time, and I've seen it where this is not always true, but most of the time, it is true that a floating input on a TTL chip does tend to act as though it already has like a pull-up on it or something, okay? So I took advantage of that and didn't bother putting in these things. But I cannot stress enough. I have seen it. I know it happens. Even with this, it's not like, oh, this one LS19275 doesn't. No. 2 chips with the exact same number from the exact same manufacturer, I have seen act ever so slightly different. Where, I think it was a flip-flop of some kind, or JK latch or something like that. Where one of like the reset input or something like that when floating was not necessarily acting as though it's high all the time. So I do as I say, not as I do. And I say that in this scenario because I know how to recognize if this thing is acting wonky. I would go ahead and put this pull-up in there. As long as it's not acting wonky, and that's the case right now, I'm okay, and I know what I'm getting away with here, okay? If you do this and you run it over to here, jump it over to there, with the diode in there, without the pull-up, it may or may not work the way you want it to, is my point, okay? So, if you're going to experiment, make sure that, Put on your learning hat. You're always learning. Don't expect everything to work perfectly all the time, okay? Always beware of every little kludge and hack that I've left aside on my board. Like I said, I know how to recognize that. So if you're not familiar with this, then just put your freaking pull-up resistors in there. Don't worry about it, because it will work with the pull-ups in there for sure. All right, so I'm on the dev branch here of the 9918. Let's go ahead and update this project and create some new Gerbers. There we go. Open up the schematic. All right, so what are we going to do here? I'm going to copy this header here. I'm going to put it up over here. Well, there seems to be some room here. Let's see here. We could just put it like over here, or I could put it over there, because A81 already exists there. I mean, conscientiously, if I put it down here, it's more in your face if you're looking at this to figure out what goes where kind of situation, and then maybe you'll notice it. I mean, I want to make sure that I don't, for example, jumper this over here to A81 on pin 5 while I'm also using 5 for something else. That would be a little bit annoying. And I know myself well enough to know that that could easily happen. Let's see here. I could like put it right there. Then, yeah, I mean, there's no excuse. And yes, I'll still screw up, but you know, hey, that's me. Let's just put a track there. And then over here, I can go ahead and, do I got a name on it? No, I do not. I could just run a line around. And a lot of people are like, oh, I don't like it when you don't put the wires everywhere. Well, you know, I'm sorry that I don't always do this, but if you just draw, you know, willy-nilly tracks everywhere all over the place, yeah, then it becomes even less readable than it does otherwise, okay? So now this wire here, when the jumper is inserted, is equivalent to adding the bodge wire to A81 over here, okay? Back to the interrupt signal, exactly as I've done on my board. Now, if you have that pull-up resistor on it or not, it's only 10K. It's not going to mess with this signal that much. If at all, it really won't have any impact. I'm not going to worry about that one hill of beans, okay? So we now need to annotate our board. Where's the, there it is, and give that a number. Okay, so there's that done. I'm going to hit Control S to save it. Now, by copying this, rather than placing a new one, if I edit this, it'll have all the ordering information, the part numbers, and all the other fun stuff, and the footprint, and everything else already with it that I already specified for this jumper 6 over there, which I think is an easier way to do this than have to start over again and then risk accidentally putting the wrong stuff in there. That's the way to go. Now, it would be foolish and, you know, I mean, stupid of me not to say what you're supposed to do with that thing. So I'll throw a little comment right there, okay? Edit this thing. Insert J7 to pull the IRQ. Let's go ahead and put the tilde on there. The VDP IRQ signal via, what was that, U6. I got to verify that. Okay, yes, U6, okay, which, when this is enabled, propagates through to D1. Now we can go ahead and add a little more on here for the people that can't follow along at home. You'll notice that this is hooked up to A8. That's the port number when we're reading from this particular joystick. So, by its on port 0xa8. All right. That way, I won't forget which port to pull, okay? When I write my code, or if you want to tinker with this, because Joy 0 here should be, it better be set to A8, which is port A8 right there, okay? So that's exactly what we want to do. Here's the newer version of my code. I'm going to go ahead and commit this independently, of course, to the schematic, but these will go together, okay? This will not work if you don't have the bodge and or if you don't have J7 installed on what we will now call Rev 2 of the schematic. So I'm going to update the date. Wow, 2020-1090. That must have been a... that probably was never updated from the first point. So always good to review all your little documentation here, okay? So this is revision 2, all right? And the date now is going to be more reasonable. Sorry about that one. And all I've done is added one track here and this jumper over there. Let's now go over to the PC board and look and see what happens here. If we click this to bring in the mods, here it'll say, oh, I've added a new part. Okie dokie. And where do we want to put this thing? All right, now the air wires here. Let's see. Let's get it rotated around here so that it looks like it's kind of in line with air wires. It would be nice to put it right there. And in theory, it might even be able to fit right there. Or maybe, I don't know. I'm going to just stick it right there to get it off the stinking mouse, turn off these things so I can see through the board. If I put it here, there's a lot of tracks right there. It looks to me like there's no room at the end over here to do a horizontal track on the front of the board, and you can't go in the back with all the vertical ones going nuts like that. I could swing it all the way down and around out here if I wanted to. It's a relatively quiet trace. No, it's 60 hertz, right? But compared to like a data line running in 10 megahertz, it's relatively quiet, okay? So from here, I can sneak a track out on the... Oh, there's a green one blocking it there. Well, I can bring out a track on the top over to here and then come down like that. And then on the top layer, because the bottom's already got this other one going across here on D3, I can run it right on top of D3 here, but that would really not be pleasant if there's any noise induced through the board, which could happen because this is a 2-layer design, I believe. Yes. Oh, we do have inside layers. Oh, this is really gratuitous use of inside layers, but that's fine. That's fantastic. That means there's a ground plane and a power plane in here between the front and the back, so this back track will not go too much nuts in radiating through the board. Yes, it's all the way out at the edge, and yes, it could be worse. It could have been done a little bit better than that. It'll be fine. We're going to run it around the outside edge. Then we can go to this here. Then it's got to come all the way to here. If I do really want it to go to A8 pin 1, it's got to work its way all the way up there. But it doesn't matter because this is totally clear on the back of the board. I can put this over here. You know what? It might even look better if I just put it up here and maybe stagger it a little bit so that it's not something that looks like you could poke a shunt up to ground or something like that. That may be okay. Let's have a look, see what the board would look like if it does go over there. All right, so it'd look like this. That would be your J7 jumper. I can move this stuff out of the way. It'll look all right. Yeah, I'm feeling like that might be okay. Okay, so what's going on down here? So what's going to happen is that our track's going to come up, down, and around, and it's going to run down along the bottom edge of this board in this dead zone out here. Come out over here and then come up this way to go to the... Yeah, I'm okay with that. Okay, dokie. What are we going to do? All right, we got a ground via right there in my way. You move it. Put it up there. Okay, look, all this extra room now. I'm going to go ahead and go to the back layer. And I'm going to just do the whole, oh, I got to get over this green guy here. What's that one? IRQ 80 right. IORQ. That, what does that thing do? It comes down here and it pops through the board there to go over there. Oh, that's the output of this is the decoder, okay? Now, it goes up to this pin right there, which is what, okay, is the enable, like the input line there. I could also go the other way. I could go out down here and around. Yeah, that's what I'm going to do. We got plenty of space over there. I can just shove this over. That's what I'm going to do. I'm on the back layer. I'm going to hit X to start a new track. I'm going to go like that and just shove it out of my way. Let the man go through. Okay, come down here. Put a via right down there. Now I'm on the top of the board. Okay. Let's go ahead and run along here. I can just come all the way over like that. I can even go over here and just stay on this side because there's really nothing else going on. Now, I'm not going to hook it up to that because what I'm going to do is I'm going to change the grid spacing. If you click this thing, when I put that down, I probably had a relatively coarse spacing. You can see the grid. I don't know, is that right? Let's see here. If I go to, you know, like 50 mils and grab the part here, if I move it around, okay, so if I move it, and you on pin 1 when you move it, sometimes you go grab something that you move it like that. Let me see if I click over here. This is like a KiCad thing. See how I've selected this pad over here and I hit M? Notice when I'm moving it now, the cursor's centered on the pad that I selected. But if I select the whole part and I hit M, it's now centered on pin 1. Now, it turns out that these two pins are 0.1 apart, and that's, you know, inches, imperial units. And in this case, it doesn't matter whether I'm grabbing one pin or the other, given the grid settings that I'm on, but I've found that your alignments can get out of whack if you're not careful on what part of the component you've selected when you go to move it. So I always try to watch and make sure I'm on pin 1, even if it's not necessary, because if you have some weird setting somewhere, you end up incredibly frustrated, like right now, I can't actually get this to align. Okay, now that's probably because of the grid that I chose. It's a pretty coarse grid setting. I could have gone to a 25 or even a 20, which would be kind of a wonky setting when I did that other. Yeah, it's probably on the order of 20, and I still can't quite get it to align perfectly, okay, which is a little bit frustrating. Now, sometimes when I do these things, I'm not always paying a lot of attention to how the grid settings are, and I like them to kind of get lined up. And it turns out that this will not align at that setting, so I'm going to go ahead and go down to 5 mils. It looks like it's off by a half a tick there, right? That's good enough. No one's ever going to see the difference. Now, with my arrow key, I'm going to take my hand off the mouse. I'm going to just let it scroll down like so, and then I'm going to hit the enter key to put it down there. And I've left an artificially large gap in here because I do not want somebody to shunt it up here or confuse it and think that it's part of this other header up there. So I'm going to go ahead and grab all this stuff, move this down, get it out of the way. I'm going to move this even down further so that it's really obvious that it doesn't belong with that, even though I want to keep it aligned up, okay? It's the anal retentive side of things. Don't forget to update your stinking silk screens when you change the rev number. Totally peeves me off when I got the wrong lousy revs on my stinking boards. There's also some backside silks that have version info on it, usually on my boards. Where is it on the back? Well, let's go see. Maybe I didn't mark it. Okay, so here's the .2. That's where my J7 is going to go. I'll then have to remember, of course, to connect the wires. Is there any text on the back? No, there's not. Okay. So I don't have to worry about updating it on the backside. That's all. And I think we're okay. I think we're doing all right. Okay. Change this to 23. Since I've just... I'm not getting any younger, people. Comma 2023, It's critically important that we protect this new jumper I just added there. It's critically important technology secrets happening here. All right, now I'm going to go ahead and reconnect this because I want to, you know, the anal retentive side of me wants to make sure that can't get this thing to do the right thing. Delete. Start over from here, maybe. Run a track. There we go. Run the track. Now, what I want to do, sometimes you go like this, and then go back here and fix this stupidity that it left behind down here. Because, you know, you don't want it to look too crappy. Right? Okay, there you go. Something like that. Save. Now, well, you can go ahead and put a few more ground vias in there. It's kind of a pain because quite often KiCad won't know where to put those. Oh, good, it chose to put it on ground. When you just place them in the middle of a plane like that. Because it's going through the ground on the front, the ground on the back, a ground in the middle, and VCC5 in the middle as well, all at the same time. So sometimes the vias will not be labeled, and then you have to manually go in the editor and tell it, oh, I want that to be on the ground and stuff like that. All right, so what I'm going to do is I can just bring it up around the outside here and then go to wherever this thing ultimately runs off to, right? A97. That, oh, no, it's not A97. It's going to this track right here, which comes up over to here on pin 5. So I can run a thingy out and around like that on the top of the board if I want. And I want. Come around down in here. Do one of these moves. Now, there's really no reason for it to be smacked up against all these other holes there, so I'm going to hit D and drag it out a little bit, and I'm going to try and encourage the ground fill on the top layer to kind of go inside there. That's a little annoying. Select that, hit M, scroll it down a little bit, get it out of the way, clean up this disaster area of routing that has left behind, and then there's a little notch in there. You can kind of clown around with this a little bit and get it to get cleaned up. Okay, that seems reasonable. Comes up here. I don't know why it decided for no reason to just put a kink right in the middle of it like that. I mean, here we are. I got a free set of tools that I think is fantastic, and yet I gripe about every little thing. Why? Because I'm a programmer, and, you know, when you see other people's programs fail and you say, oh, this is terrible. Now, this could be an acid trap. In the old days, everybody would go nuts about that. I still get a little bit concerned about them. I'm going to go ahead and do this, get rid of it. Oh, this is kind of gnarly looking mess over there. That's okay. There's no reason for these to be rammed up right next to each other. All right, so we're looking pretty good. Turned on the fills again. Now, you can't see it and everything's shorted out. So I hit B to re-pour the polygon. All right, we can see the ground float around it quite nicely. It's up inside there. It's all looking pretty good. Pretty hunky-dory. All right, it comes out and around down here. These are kind of close, but not too bad. Comes over here. All right, now did I leave a mess over here in any way? Let's turn off the polygons. Let's see what's going on. So it pops up here, comes up through there. Bing, bang, bong on to number 16. Now, this is a little busy feeling over here. Let's clean this up a little bit. Bring that over there and bring this up like this over here. No reason for these to be all crammed in there. That looks pretty good. All right. What's this one? That's the read line. Now, if any of these signals ends up getting on that interrupt line, it turns out that interrupt line, if it's just being used to pull the frame, if there's some noise on it, it's not the end of the world. But if that's an interrupt line that goes to the Z80, you might have a problem. So you do not want to get it too close to everything else. I'm going to hit B to report the polygons, turn on the polygons, give it an eyeballs or anything weird going on there. Let's go back copper where the tracks are, okay? It'd be nice if it could find its way up and through here, but does it really have to? No, not really. It's okay. I think we're in a pretty good shape there. Woohoo! New jumper in there. I mean, honestly, you want this thing on all the time. Just leaving it set the way it is right now, the only value of this is for experimentation. And I'm thinking out loud whether I should put a cutaway trace between these two so that it's actually got copper through it. And if you want to experiment, you would cut it and then put the jumper in, that kind of a thing, you know. Let's go ahead and leave it the way it is. For crying out loud, this video is going on an hour as it is. I'm looking over here at J6 for a very specific reason, and that is for another set of experimentation. If we replace that with a 3-pronger, and we put this signal to pin into a middle pin, and we put a shunt in this way, it's going to go to the interrupt line on the Z80. What we could do is add another pin over here, is my point, and connect that up to the non-maskable interrupt, which behaves in a completely different manner than interrupt. And by that I mean it does not have a mode. It always goes to one and only one handler address. And that can be quite convenient if you really do want to generate interrupts from the VDP and you want to be running in mode 2 because maybe you also have interrupts going on with the SIO and or the CTC. And that technique is actually used on the, what was that? I believe there was a Z80 home system that did exactly that with the TI-99 VDP. Oh, what was the name of that piece? I'm embarrassed. Well, that's what the comments are for below on YouTube. Remind me which machine did exactly that, will ya? Okay, so what I'm going to do is I'm going to jettison J6. I'm going to replace that with a three banger. That's like a con _01 X like 03 or something like that. Yeah, one of these. There you go. If not, you get to scroll for an hour and a half looking through everything ever invented in KiCad to find the part, but that's better than nothing at all, right? So what I'm going to do is I'm going to change this. I'm going to call this one J6. All of a sudden, grew another leg. And what am I going to do? I'm going to put it up here. I'm going to move this out of the way. I'm going to take this, and then I'm going to rotate it like so. There you go. And then, I don't care what that thing, turn that off. We don't want to see that stupid thing. J6. All right, one of these pins is going to go to the interrupt line like it does now. Maybe that's the top one. This will depend more on the way it turns out to be oriented on the PC board and whatever can fit in there, right? So I'm going to go ahead and highlight this whole thing and hit, what am I going to do? Hit Control-C on it, Control-V to make a copy of the whole thing. And I'm going to put this one on the NMI. Save it. I'm always reminded, every time I type in NMI, I hear Johnny Rotten singing about EMI in my head. And of course, as an engineer, we all know that EMI can be a very bad thing. Electromechanical interface is what I'm talking about. John Lydon, I'm sure, was singing about the record label and his displeasure with some arrangement that possibly might have gone awry with their group, is my point there. So let's go ahead and find a, what do we call this thing? One of these Pinman headers. Now you got to get the 254. Once in a while I pick the wrong ones. Oh, so very frustrating. We want imperial ones if you're going to use the regular old shunts, okay? So I'm going to go a 103 vertical. Oh, gee, come on, people. Left, right. These are these like, ooh, that's a surface mount jobby. Horizontal, vertical. There you go. There's the bad boy. I'm not going to bother putting parts and stuff in here. I'm going to go up here and I'm going to delete this one. Save it. It's a header. I'm sure you can find something on DigiKey, or that's comments below if you got your favorite supplier on these. And that actually might be really useful, by the way. Please do put comments below. These things add up in price after a while. And if you buy, I need to buy a 3-pin, or, don't buy a 3-pin header. Just buy a giant one and snap it into pieces. That way you got a 3-pin for this, and your leftover pins you can put over there. You can put, any of these single row headers you can use for all these little shunt blocks on your retro main board and stuff like that, okay? You can also put 2 of them in a row right next to each other on a header like this. But if you do that and you're new to this whole thing, be careful how you solder them in so they don't end up like pigeon-toed or akimbo. Then you end up with not being able to put your header and stuff on these things. So be careful about that if you go that route. So I'm going to save this, go back to the schematic. Go back to here again, turn off the fills, grab some new stuff. Oh, look, you just added a new dingus and you deleted an old one. Okay, update it. Thank you very much. Close. Now, you'll notice the other one went away and this one showed up. Now, we need to make sure we can shoehorn that sucker in there. Now, interrupt and NMI, I think, are really near to each other. I think it's like right there, but it's not labeled. Because in the schematic, I never labeled it over here. Ugh, I am sure it's this one, but if I'm wrong, I will be very upset. So let's look that up, shall we? So I'm going to Control S to save this. I'm going to go ahead and back to the circuit board and Control S to save that. Control W, or what is it, Control Q in this window to close that one. Now be careful with Control Q, because somebody in their brilliant genius changed the meaning of Control Q by default in newer versions of KiCad, and it'll close the entire thing out and blow away your whole windows and everything else. Not that you can't just start up KiCad again, but they've changed that, just FYI. I'm going to go up here to File and go to Recent Projects. Grab the whole retro board. And double check what is over here. It is. It's on 17. Now, if you go in here and you go like, ooh, if I go to go like this, highlight it and hit Control C, I'm pretty sure it will not still be there by the time I go over here. And go back to my other one and go into here. Let's see what happened. I don't know. What happens if I hit Control V? Nothing to paste. Okay, maybe they've improved that since this is KiCad version 5. I'm still on 5 here, by the way. Go in here and hit delete, and it says, oh, I don't know what you want to delete, so pick that one, please. NMI. Go in there. Okay, my friends. Now we've got what we are in need of. Okay, save. Now, when you put the bar on top, notice I put a single tilde over there. You can put a tilde on the end as well. What that really means is start putting an overline and then finish the overline. But if you do this, I suspect that label is different than this one. So you got to be really careful with your net list. If you're going to do this, stick to very strong conventions. You saw me do another one over here where I had 2 tildes. That was because I don't know what happens if I don't keep it going there. Well, the whole thing, yeah. See, that's why you need to be aware of when you do or don't want to do this. I've noticed a lot of people, if you have a single word with an overline like I do here, we'll just put a single one on the left and leave it at that. And that's okay, but be careful because it may not mean what you think it does when it comes to matching other labels in this same drawing. All right, now, if we look closely and we import again, oh, someone just added a label to something that was previously not labeled. Okay, so now if we leave it in this orientation, we can run a track to the top one, track to the bottom one, and the middle one can snake around and out and come down here. You do not want to move this down here, because if you put it down there, you could jumper it to the middle, but you couldn't then jumper it up to here. This trace has to be in the middle, okay? So don't lose track of what the purpose of these things are. We've all been there, right? Oh, look, I've optimized this. No, you haven't. You've ruined it. I'm not going to say anything else about that. Okay, moving along. Move this into here. Let's see if we can shoehorn that sucker in there. Now, of course, it's going to yell and scream about overlapping parts when we go to do the design rule checking. But we know it's going to fit. Now, I don't know how much I want to keep this aligned with the other pins here. Again, I don't want to think somebody might put a shunt across there, so staggering it might actually be a good idea. I'm going to take this ground via and get it out of my way. Okay. You can go ahead and like stick it in a place like that if you really want one. I don't think I care about it. I'm going to delete it. I think the only reason I did it was so that I could add a little bit of copper in this general area. There's a pin right there with ground on it. It'll cause the polygon to flow over there. Yeah, it was up here. I don't know. It's starting to get busy over there. I think we're going to be fine. All right. It was fine before. It'll be fine now, right, people? Let's see here. Now, these lines here, this purple one there and the blue one on this guy, these are the silk screen borders on these connector pins. The reason this one's purple and this one's blue is because this one's facing down and this one's facing up, by the way. But my experience is that you can actually see the silk screen around the base of these headers as well as on the socket housings. And therefore, as long as these drawings of the silkscreen outlines are separate from each other or overlapping, coincident, then I think we're going to be okay. Okay? And it's actually not even inside coincident with the chip on the right here. I think this is going to be okay. This is really pushing it. These white lines around here, the courtyards do overlap, and the DRC will gripe. But and somehow I will get over it and find a way to sleep at night. So I'm going to hit D to drag this around down there and reroute it. So let's go ahead and hit X now. I'm on the front layer. I want to get on the back side. X this thing right there. Come around. Go into the middle hole. Now go on the front side and say, okay, what am I going to do? Yeah, this looks pretty good. I can go from here. Come on. Right there up to here. And I can go from right there over to there. All right. Save. Hit B to report the polygons. Have an eyeball on the polygons. Now, I generally like to make sure that the polygons kind of fill up and consume a lot of the space in here. I don't think it's critically important that it does. Some other people have said that it's pointless to go ahead and have the ground fill on there. I mean, there were days yesteryear where the board might curl up like a Pringles potato chip if you didn't have the same amount of copper on both sides. I've had board fab houses call me and say, we want to add thieving to your board. We want to have enough copper and a percentage basis to kind of evenly cover the board. And what that is usually in reference to is when they do the plating process. If you don't have a kind of a consistent copper distribution around the board, then what happens is when they do the plating, it will not evenly cover your board. And that's when they put thieving or raindrops, little dots or crosshash on your board to fill it up to give it copper in the general vicinity. And the plating that they're referring to is when they go to plate through all the holes and stuff like that. So if that happens unevenly, you can end up with holes that don't have plating inside of them, and all hell breaks loose, and that's very undesirable. So I still put the copper everywhere. comments below. Am I an idiot? Am I not an idiot? Am I living in history? Is the being born on the on the border between baby boomer generation and the Gen X generation? I call myself a boomer X. So am I in touch with my boomer there, or am I a Gen X? I don't know. Anyway, the point is, we all have stuff to learn all the time. Let me know if I'm making things difficult for myself and or others in making these decisions. All right. So what I just did there is put a triple header on there. It's a three-peat. And I think that's going to be just fine. I could put some silk on there. All right, let's put the silk on there. This is why it takes 9,000 hours to build a board. Constantly questioning every little thing that I do. And, ooh, should we do this? And, in all honesty, I think it's actually it ends up being a good thing. I like to copy something and edit it because the font's already been set and everything else. And of course, that's not going to fit for dork, is it? Now, if you use the cheap board fab from JLC or something like that, and I use them all the time, I'm absolutely thrilled that I can get boards for so cheap. However, these are not top-notch, A-grade, super high-quality boards. And in this scenario here, in this case, you will see that even this font looks blurry and doesn't look that great when they do the silkscreen. If you pay for a better board, the silkscreen is so crisp, so clear, you can put little teeny text between these pins, and it is perfectly crisp and clear. Something any smaller than this is not going to fly, so I'm going to go ahead and delete it, and we're going to just have to suffer with not being labeled, I guess. It wasn't labeled before, so, hey, at least it's better than it used to be, people, So, for backward compatibility, you would put the shunt on top, if you ever did before, and then this will be nice, because we can go ahead and do some experiments with the NMI. And even with your older board, if you're, I built mine already, and I want the new one, well, don't worry, because you can just take a little wire or a jumper and stick it on here, and remember, if you use the long pin headers over here, there's a pin sticking up there, and you can just take a little wire and connect it from the IRQ pin on the 2-pin header, and then connect it over to NMI like that. Just like you can also take a connector on the current 2-pin header and run it over and plug it in over here, wherever the right pin is, rather than use this. Okay, so this is a pretty small change. In fact, I should have called it 2068.1.1 or something, because this doesn't really cause any major problems. I moved on to .2 because what will happen is this software will become incompatible if we're pulling this pin here rather than the VDP directly. And, there's other ways around that too. You could actually write a routine that pulls continuously and counts in a register or something like that to the point where it absolutely must have pulled long enough to see a frame flag pass by that you did not get. And if that is the case, your code could fall back to using the old version of the polling code and read the register directly and put up with the fact that it will stutter and jump around, but it's better than not working at all. Okay? Maybe that'll be another video I can do and show you how to do stuff like that if it's not already obvious by just having the idea planted in your head. All right, so I'm going to go ahead and make some Gerbers and look at them, maybe I sleep on it overnight or something like that. Make sure that this is all right, because when I edit stuff while I'm talking, I don't know what kind of foolishness I may have forgotten about and made, there could be a bug in here. So let me know in the comments below if you have any thoughts on that subject. But look forward for release revision 2 of the VDP board coming to a GitHub near you. All right, thanks for watching. I'll talk to you later. Bye-bye.